Hi everyone, this is Piers, Ridyard, CEO of the decentralized finance protocol Radix, a layer 1 protocol entirely dedicated to bringing DeFi into the mainstream. Today, we are going to be doing a session with one of several sessions with our head of product, Matthew Hine, who's going to be taking us through some of the thinking that has gone into the creation of Scrypto and sort of the underlying design philosophy and the learnings that we've had along the way to create the product that we'll first release at the Alexander Preview event as a preview on the 12th of November in New York. If you want to come to that, please do come. You'll get to meet Matt in person. You get to meet me in person. You'll get to ask some questions and do some workshops. And then later at the end of the year, when Alexander is actually released, you'll get your first chance to actually play with Scrypto and start building things off ledger. So I think that starting with just the almost the highest level of abstraction, right? Furthest from the details of how we've actually done things, like why we started to want to address this problem, what problems we saw in the space. So it'd be great if you could just start off with that.
Yeah, sure. And it's a good question. I'm glad we get to start here because it's kind of a common question. Like, I think more often than not, when I'm talking to people that are just coming into Radix for the first time and they're asking, and they want to talk about the buildability aspect, the smart contract aspect, the assumption coming in from people is usually, okay, so you're going to have EVM compatibility, right? Like that's just when are you going to get EVM compatibility? That's obviously the answer. It's just a matter of how quickly to get to that. And so I always have to back and go, well, wait, hang on, actually, is that really what we want? And so the first article we've just put out here and what I wanted to talk about today was how that's really what we've found over quite a bit of time of research is we've discovered that this probably isn't the right approach to the whole thing. Like this is actually one of the mistakes that we think other projects are making is just assuming EVM compatibility is the end state of what smart contracts look like. A lot of this came out of some of the interviews we've been doing with DeFi projects. One of the great things about having you network with DeFi projects when GoodFi Piers is the fact that it means that I get to kind of follow on your coattails and ask questions of these projects. So that, and then also talking to community developers and other people, we were starting from this place of we're building Radix in a pretty different way than other protocols. And so this gives us the opportunity to explore how do we want to implement smart contracts? It's going to be a little bit different at minimum, but how different, is there something there? And so when we talked to these projects and developers, what we found was that there are a lot of problems, to be honest. Like there are a lot of real issues with, all the way from kind of the individual, very tech-focused developer to the entrepreneur who is running a DeFi project. It's not a rosy picture of what the smart contract. And so we started digging into like, well, what's actually wrong with these smart contracts and what the issues? Some of them are really obvious. Some of them we see every day, but you kind of forget about it. Like in DeFi, you see that you have frequent exploits. I forget what the last one was just last week. Like every week there's another one.
I think it's over $1 billion of exploits and hacks in the last 2 years in DeFi.
Right, exactly. Like Adam always points to, I think what's the website like Wrecked? There's like a website that basically
Rect.news.
it's just a catalog of these things. And this isn't the result of stupid developers. This is the result of, and what we found is it's just the wrong tool for the job. Like there is this assumed paradigm of how you develop smart contracts, which makes it almost impossible for even a really good dev to build something that isn't going to be susceptible to these kinds of exploits. And so that's, to me, indicates that it's just a tool that's not up to the job. It's not like, if we're talking about, one of the things that I always come back to with everything with Radix is the scale of what we're trying to solve. And this is something you've talked about too. We're talking about DeFi as DeFi is the way in which we're going to remake the global financial system. This is hundreds of trillions of dollars. And our focus is always on what does the technology solution need to look like to be able to fulfill that kind of potential. And so this gets into our approaches to scalability and all these other things. But on buildability, on the smart contract approach, I feel like this is just as important. And in some ways, the scalability questions sort of conceal this. It's like scalability is the thing that's really front of mind for people because it's an upfront problem. Like everybody who's used DeFi sees that it's like, oh, fees are really high, throughput is low, this sucks. Somebody's got to solve this. And you're right. But in some ways, because that's the big obvious problem, you miss out on the fact that the people that are in DeFi today are kind of risk takers because they have to be, because these things are constantly getting hacked and exploited. And it's also concealing the fact that the growth of DeFi is really limited by the fact that these tools are so difficult to use. So anyway, we wanted to dig into like what specifically is actually wrong, and also looking at it from the point of view of what does the right smart contract approach need to be able to fulfill that potential of scaling DeFi up to hundreds of trillions of dollars. And behind that means this isn't just, hundreds or maybe even thousands of developers that we've got in DeFi today. They're all kind of crypto enthusiasts. This is scaling up to the point where we've got millions of developers that see this as the big opportunity for them of the next generation, which is what it should be. This should be the thing that every developer is going, oh my God, this is where I'm going to make my name. This is where I'm going to launch the next big project, is solving finance in a more democratic model. This is an enormous opportunity.
Right. And I think that you're absolutely right that this is if scalability went away, the next thing that everyone would be yelling about would be how often things get exploited and hacked, and how dangerous it is. And it's really like there's things that are obvious that that's a problem for, but then there's things that are less obvious that you only think about as like a second order effect. One of the second order effects is that developers don't want to build DeFi applications. They look at Solidity, they look at coming into DeFi, and they go, wow, DeFi sounds really exciting. And then they come and look at the tools and they go, hell no, because a lot of people don't want that kind of stress. Like it's one thing to take a chance on a business, it's another thing to take a chance on people's money, and then a third thing to then do those two risky things with an incredibly risky set of tools. And actually that risk profile cuts out way more developers than you would realize.
A huge number, yeah. Like, I mean, the majority of people that developers see this stuff. We've talked to a number of developers outside the crypto ecosystem, and like, I've had this conversation a few times where they go, oh yeah, this seemed like it was a lot of buzz about this, and people were talking about Ethereum, and so I came and took a look at Solidity, and their conclusion was like, oh my God, people use this? Like, this is ridiculous. There's no way, like, I'm going to come back when this is ready. This isn't clearly ready yet. So right. Yeah, there's this huge filter that goes on where you get this very narrow set of developers that basically go, I don't care how bad the tools are. I want to be here anyway. In fact, there's a whole other thing. There's this little video I want to shoot called Ethereum Island that I'm going to be coming out with the next couple of weeks that talks about this in depth, about this story of how people get into Ethereum and how difficult it is and the problems people have.
Right, and then this sort of leads into the second order effect, which is that using Solidity is really hard, it ends up being very slow to build things. And so that slowness means that actually, while it can feel like DeFi is moving very quickly from the outside in terms of how much capital is coming in, but in terms of how much real innovation and change to how the fundamentals are done, what you'll notice is each DeFi protocol is actually quite a small little, from a technical point of view, little additional tweak on things that have been tested, because the risk of doing something from scratch or completely changing a paradigm is just so large, because it's really, really difficult to make these things secure in Solidity. So developers spend like 90% of their time securing rather than building functionality. And then the third order effect that happens is that DeFi projects really struggle to get talent. Like, you can have the best funded DeFi project. We've spoken to fantastically funded DeFi projects who are really, really visible, and and a lot of them, you ask them what their number one problem is. They're like, talent. Can't get good Solidity developers.
Over and over again, yeah.
And so that all comes into problem number one. So your sort of your first order, your second order, and your third order effects all compound on each other. I mean that you have an industry that is trying really hard to push through all of this difficulty. It's sort of like swimming through. It's like swimming through syrup. It's possible.
But yeah, it's a surprisingly conservative development field for something that's like brand new, and it's like, oh my God, there's this whole way you can rebuild things for the first time. But yeah, everything is very conservative. People are just taking any code that has been proven to last for a few months without getting hacked and going, okay, we're starting with that, and we're going to make the smallest possible change. And the result, actually, the smart contracts themselves, even the most popular ones, are very simple in a way. Like, the code is, they try to keep the code as minimal as possible, to just try to minimize the opportunities for risk, and to minimize what they can get built with the resources they have. So like what we looked at is the interesting, this is this big wide ranging problem of like, well, there are these issues with smart contracts today, but what is the root cause of this? And what we found is it all really does distill back to the tool set itself, the way smart contracts are written on Solidity. And well, I mean, I'll get into this a little bit later, but I think what we've found is that you would address all these problems if you had a smart contract environment that had 4 attributes. It needs to be easy, it needs to be safe, it needs to be reusable, and it needs to be composable. Those 3 things, easy, safe, reusable, composable, are the places where it isn't just Solidity. Like Solidity is kind of like it's the topmost layer of it. It's the way Ethereum conceptualized smart contracts in the beginning. And this goes back to 2013 when they first came up with it. They came up with this revolutionary idea of running smart contracts running code on a decentralized ledger. But the way in which that's done is really causing a lot of issues because it wasn't really done with DeFi in mind, because DeFi wasn't a thing in the beginning. It was just sort of like, oh my God, this is possible. What will people use it for? We don't know yet. And I think what we found is the biggest use case. I'm convinced that 99% of the value of these ledgers is going to be DeFi, and I use DeFi in a very broad sense.
I think that those 4 attributes are really important: easy, safe, reusable, and composable. And they're interesting for lots of reasons. We'll go, and I'd love you to talk about each of them in turn. But they're interesting as a framework for assessing whether or not something else is suitable. So you are seeing other layer ones that are looking at integrating other languages, like the whole WebAssembly thing. Oh, you can use any language you want out of this roster, so you can write in smart contracts in C or in Rust or in Go. Or you are seeing platforms like I'm going to completely forget their name. Cardano, who is pursuing Haskell as the language, but that's only focusing on one bit of it. It's not focusing. It's focusing on the safe bit. Like, how do we get more formally verifiable languages? How do we get languages that are better, purpose for finance? But actually, that's only a small part of what the language has to do for it to be properly good and properly intuitive for a developer to pick up and use and build decentralized finance specifically. So let's go through those 4 attributes: easy, safe, reusable, and composable.
Yeah. So easy, and easy is where I start on this, and it's a really important one. And I use easy in a very specific sense, and it's really important. It's sort of what we mean by safe is another one. What do you actually mean by safe? Easy. What I mean is not I think the approach that a lot of easy is something that I think a lot of even Solidity, except Solidity selected JavaScript as their syntax because I think the concept was this will make it easy as possible for people to jump in and start building code. What I mean by easy isn't sort of time to first DApp or okay, I'm writing my first bit of code or understanding at the beginning. It's really about that total learning curve to get you from 0 to. I haven't just deployed a DApp. I've deployed a featureful DApp that's actually doing business. It's managing, millions of dollars. I've got lots of users. It's operating business as usual, and it's supporting that in the back end confidently. Getting from that learning curve for Solidity is extremely steep, and this came from a lot of the interviews that we've talked to. If you kind of drew the learning curve out, when you first put your feet in, it seems really easy. Ooh, JavaScript. Everybody knows JavaScript. Cool. Well, I can start writing stuff. I can write a little hello world thing. I can deploy that to Ledger. Oh, wow, this is super easy. I did it in the afternoon. Then you start copying other people's code. Oh, okay, yeah, there's other people that are doing stuff. Wow, this is great. And then you hit then suddenly you hit the knee in the curve. And we heard this over and over again from people that have gotten to a level of expertise with Solidity, is that you suddenly reach this point where you have to get through years of trial and error, of learning from what the other people's mistakes, of really understanding how, not just copying a piece of code, but really understanding the iterative process that led them to writing that code in a certain way. And a lot of this came back to, there's the very interrelated issues of easy and safe, because a lot of it comes down to the complexity of writing business as usual code that is safe. And so that learning curve is extremely difficult in the EVM model. and basically every other smart contract model, because they're basically copying it. And in fact, this kind of gets into what you're saying about Cardano's approach, is it's something this formally verifiable Haskell approach that actually goes the other way. It's saying, well, we're going to try to make things safer, but it actually makes it even more difficult to come up that learning curve. It's a different way of thinking about the code. It's a very sort of complex structure they put in. And in some ways, once you get through the more complex Haskell syntax, at the bottommost layer, it's still basically the EVM style paradigm. It's not really changing the approach to the whole thing. And I'll talk about what I mean.
Maybe it's not easy. It's intuitive. I'm trying to think of like some corollaries for this. But like anyone who's done world building in like games, anyone who plays games, and like you different games have different world building mechanics, and you'll have definitely experienced some world building mechanics which try to be expressive but are incredibly complicated to use, or like are just a pain in the ass. I can't think of any examples off the top of my head. And then you have other world building mechanics like Minecraft, which is incredibly easy. It's a simple set of tools, but the tools end up being quite expressive, and you end up being able to be incredibly creative with them. Another example would be, anyone who does 3D design, SketchUp, which is a Google-made tool, which was very easy to make, simple to make, like basic shapes of like buildings. But as soon as you want to do something more complicated, like you need components because you want to make a manufacturable thing, SketchUp becomes the most insanely stupid tool to use for that. And suddenly you need the next level up. You need something like Autodesk Inventor, which has a slightly steeper learning curve at the start. But once you get to the point where you understand the tool set, suddenly everything's intuitive. It all comes together and you can do all the assemblies, and complexity is part of the intuitive way in which you build, rather than something you have to battle against, which is what happens with badly made tools for building.
Right. It's not purely this matter of sort of like, well, you've got like the oversimplistic play school version, then you've got like the complex fully. Like there are points in which the tool set, like the concept of the tool set, is pushed forward to realize, what this tool is really useful for is this. We need to build the tool around making that as easy as possible. Like the CAD metaphor is one that I can get behind, because I've got CAD experience from my background. Like I remember back in the 90s when you're talking about CAD, it was all about sort of these like geometric primitives. It was sort of like everything was. It was basically thinking about it in this very computer sciencey sort of way. It was like, okay, you're going to put things together the way the computer thinks about it, right, and you'll be able to build up objects. And in the end, and it was really worky, but everyone was like, well, but how else are you going to do it? This is what computer-aided design looks like. And then suddenly realized, that's not actually what computer-aided design is about. What it's really about is designing products that have certain features. Like you need to think about surfaces and skins and all these sorts of things. And so they rebuilt the tools to give you the ability of doing those things as the native language of the tool set they're using. And then behind the scenes, it translates that into the machine language. It handles that for you. And that's what we're finding is really needed. So it's that when I mean ease, it's like there needs to be a tool that allows you to get your feet wet quickly, but then get all the way to like the full power of like a really complex thing in a very intuitive way that doesn't force you to sort of like onboard all this additional making up for the tool set complexity. And this is what creates a lot of the problems that we mentioned at the beginning of like the hiring pool. Like this is a direct result. The hiring pool issue is a direct result of this. It's because the majority of developers come in and they can see that learning curve coming. A smart developer looks at Solidity and they go, yeah, I can see how I can build something. I can write my first piece of code in an afternoon, but I don't see a path to building something that's secure for a really long time. I'm not even get started. This is just not suited both for the task. And so you just don't get enough people coming into the ecosystem because the tools are just not suitable for it. And this also has a lot to do with it. Again, it's very closely related to safety. So I'll move on to safety because that's the next one.
Yep.
Like it's very closely related to ease because in our opinion, and this gets to our approach to Radix Engine and Scrypto that we'll talk about on the next time. We feel like those two are really related things. Like you can't solve easy at the sake of safety, and you can't solve safety at the sake of easy. Like again, like the Cardano thing is saying, well, okay, if smart contracts aren't safe right now, what we mean by that is that if I write a piece of code, safety means how confident am I that that piece of code is actually going to stand up in the real world? It's not going to be exploited. It's not going to be hacked and so forth. And so Cardano goes, well, okay, what we're going to do is we're going to put in the system whereby the piece of code itself can be formally verified. And so people will have a greater level of confidence and safety. But as I mentioned, it comes at the expense of making it easier to use, which I think is not a good compromise. And the other thing about it is that I feel like that approach to safety is the wrong direction, because when you're talking about safety specifically in DeFi, what's the most important thing is safe management of assets. Like, that's all that matters in the end is the money going to the right place? Is the money is it behaving in the way it's supposed to? If I'm putting money into a pool, is that money only moving out of the pool according to the rules that I would expect, or is it like, did someone find a way in which they can change the authorization of the smart contract and can pull money out to this other thing and then, pull it out of the pool and do something with it? So formal verification doesn't really directly help with that problem. It's like, it sort of helps you verify that there aren't, in theory, it helps you identify that the code behaves in a certain way, but translating that to making sure that this very sort of a high level concept of asset movement, ensuring that means that, like, well, someone isn't going to be able to exploit this oracle in order to manipulate the price of this and do something with it. To be honest, formal verification doesn't really help you much with that. So
right. It also gets in the whole way in the first place, which is like, these tools need to just be able to be picked up and used, and the fastest point to being able to be expressive in those tools is the most important thing. And if you're going Haskell, you now have to understand how to write formally verifiable language, how you think about coding in a completely different way. You have to change so much that what's much more likely is people will come and hack those tools in a way they don't really understand. How do I do this? Stack Overflow, like whatever. Like, those are fine to start off with, but like the learning curve is just so difficult. And actually the end state is still, you're not getting anything for free. Mm-hmm. It's just a different way of expressing the same set of problems in the first place that is in Solidity, which is that the way you architect things is also kind of insane, which we will definitely be talking about towards the end of this call. So let's go on to, if that's okay, to this concept of reusability.
Yeah, well, actually, if you wouldn't mind a quick digression before we move on to that, because the easy and safety together, we feel like the right solution to that, those two really go together, right? And we've been kind of talking around this. I wanted to give a quick example, and this is in the paper, and you definitely should check this out. But I think it's important to understand, like, the nature of the relationship between those two things and just how real that problem is. It's not just sort of like an abstract thing of like, well, yeah, okay, easy tools, that'll help some things. Like, this really does express itself in today. So one of the from what we've heard from a number of people is that the most respected piece of smart contract code on Ethereum today is Uniswap. Right. Like, people go, they're like, that's a really elegant implementation of what they're trying to do with swapping. It's like, it's designed for as much efficiency as possible. It's, and it hasn't been exploited yet. It's a good piece of code in Solidity. I don't think most people understand really what went into getting to that point, because Uniswap is conceptually not at all what you'd expect it is. And I don't blame the developers. I honestly think Uniswap has fantastic developers. But it's a matter of like them working within the tool set. If you think about Uniswap, like the simplest idea of like, if you imagine how this works is, I've got some tokens. I send those tokens to Uniswap. Uniswap does a little bit of math. And it pulls some other token. If I send you token A, it pulls some token B out of the pool and sends it back to me at the current exchange rate. And the exchange rate is set by the relative values of A and B in these pools that it holds. So, like, in concept, it feels like, oh, that's actually really simple. Like, there's not a lot to Uniswap. There's also like the LP contribution part of it, whatever. But if we just focus on the swapping thing, it's this really, you expect you could just write a piece of smart contract code that just kind of goes, okay, if someone sends me A token, then I look up the exchange rate, and then I send B token back to them. Pretty straightforward. But if you actually look at how the smart contract works, I think it shocks, once you dig into the code, it shocks people just how convoluted the system concept of it is, because of the way Solidity and the EVM model forces them to do it. And the first thing is that you don't actually, there's no inherent concept of sending a token to the smart contract. This is what the user sort of believes they're doing at the top level, but really each token on Ethereum is its own little smart contract silo. And again, I'm not going to go into the full detail of this because we've got other stuff on this. But if you imagine, token A and token B are each their own little token smart contracts. And the way in which you send that token is you send a message to that smart contract that says, hey, I would like to do this send. Can you please adjust these balances that it means? It's basically just this list of accounts and the balances associated with each one of them for that token. So immediately at this point, this swap takes a different form where he said the way this actually has to work is you have to first give permission to the token A contract that says, well, there's this contract called Uniswap. It's going to be doing a send on my behalf. And then the Uniswap contract, in order to do this swap, it says, okay, I see that the user wants to request a swap of A for B. It goes to the A contract and it says, okay, I'm going to now adjust this balance, from their account to my pool account. And then it goes to the B contract and says, okay, I want to adjust the balance from my pool to their account. And then it's going and it's looking at the states of those contracts. It's updating some internal caches that it has because it needs that to do the calculation. It becomes this very sort of convoluted multi-messaging thing, and every one of those messages between these different smart contracts becomes another opportunity for error. And again, this is like the simplest possible thing that you can think of doing in DeFi. Like once you get into flash loans and these other things, it gets really crazy. There's a diagram of this in the article about this, which I encourage you to look at.
It's a great diagram, and it starts to you to understand like how the concept of objects that you would expect to be native of a platform, like tokens, are not native of the platform. So on Ethereum, like what Matt was saying, your ERC20 contract defines both what a token is. So it completely defines every single time an ERC20 token is created, you are writing to the ledger the rules about what makes a token a token. Mm-hmm. So you're just repeatedly making the definition of a token when you create an ERC20 contract. And the other thing is it's the list of all of the current balance holders of that token. So the balance isn't held in a different smart contract. The balance of token holders is held on the ERC20 smart contract. So if Uniswap is trying to change any tokens, it's updating balances. It has to update balances on smart contracts that are not its own smart contracts for it to actually be able to execute what it does, which kind of leads to this insane, almost Rube Goldberg type mechanism that makes it incredibly unintuitive. Like one of the things that I have loved about watching the product process that you and the team have been doing was this expression of like, we want how you would draw the thing to be as close to how you actually express the thing in Scrypto code.
Right.
And in Solidity,
it's just not. Yeah. In fact, it's weird. Like even the weird thing is that the Uniswap smart contract is the LP token ERC20, which is this weird thing. But it's like, that's the most efficient way of doing it. It's like, right, well, we're just going to have this silo that keeps the balance of LP tokens, but also is implementing all the logic. It's nothing like you would draw the thing. And that, what you mentioned, is exactly how you get to this end state that we want. We want something that is safe and easy at the same time. If you can implement a new form of smart contracts, if you can come up with a new paradigm that allows you to go, Uniswap should just be this thing where I send us a token to this thing, it does a little math and it sends me a token back. If you can write code that looks like that, you cut out 90% of the complexity in the Uniswap smart contract, and you cut out 9/10 of the opportunities for error in this thing, and 9/10 of the places where, like, well, if this message isn't happened properly, then I need to have to write this piece of logic that then sort of falls back to this other state, and like all of this sort of conditional if-then logic of making sure that things get managed properly. Most of that should just completely go away. It's not as if we've made it easier to write that code. You just don't have to write that code to begin with, because you can go directly to the system functionality that you want. You don't have to sort of work around the fact that you have to work with these different silos. So this gets into this asset-oriented approach that we want to talk quite a bit more about in the next couple of months.
Right. So, I mean, like, this is just laying the groundwork for the really important concept here of Scrypto, which isn't just a programming language. It's a programming paradigm powered by a programming language, where we are adjusting the paradigm in which you would express financial decentralized financial applications, to make your intuitive, because the brain's such a great intuitor of how you should build things. And if the closer you can bring the intuition to the tool, the faster we think that iteration and innovation can happen. And actually, as a result, better code will be written as well, because the way in which you express yourself in the tool is as close as to how the tool functions, or the code functions. And
Yeah, you're absolutely right, and it's not just, and you're also dead on. That's not just the language. It's easy for people to focus on that, but the second article in the series that talks about this stuff is actually not going to talk about Scrypto at all. It's going to talk about Radix Engine, because Radix Engine is essentially our form of the EVM, of the Ethereum virtual machine. It's sort of the mechanism that the platform, it's the environment that the platform offers in which the code is run. And that is where you have to start on the solution. You can't just operate at the smart contract level. Ethereum, the EVM, can actually run multiple smart contracts. Solidity is the one that most people know about, but there are a few other languages that are out that you can run on Ethereum today. And none of them really change this fundamental operation of the thing, because the language is limited by the features of the platform. And so what we're saying is the platform has to be redesigned. And this is why, in my opinion, why we don't see a lot of this happening right now already with other platforms, is that you really have to go back to first principles and think about what are we trying to provide. And to be honest, most other DeFi protocols are, again, going back to the beginning of our conversation, they're just saying, well, we don't want to be too different. We're just going to implement something like EVM. Sometimes literally EVM, sometimes it's very similar EVM, but maybe it's using Rust instead of JavaScript. It's something like this. But just changing that top layer doesn't really change this fundamental problem with easy, safe, and reusable and composable. To solve that, you have to start with the platform. So we'll be talking about Radix Engine next, how Radix Engine reformulates this. And then Scrypto on top of that really just becomes a gateway into Radix Engine. It becomes, here is how the developer accesses these platform features.
So let's talk about those last two concepts, reusable and composable. So
right, yeah. So reusability is a really interesting one. It's kind of a multifaceted thing. Like one tangible place to start is, again, what we were talking about with tokens. The fact that even though DeFi itself is, decentralized finance, the whole concept of finance is assets. It's the management of assets and doing really wonderful things with it. Even that core concept is forced to be implemented over and over again on Ethereum. You have to deploy an ERC20 contract or an ERC721 or all the different kinds of tokens for each individual token that you want to issue. And so it's, you can make the argument the ERC20 standard is something where, well, okay, people are reusing that standard. And the standard itself actually doesn't, and this is something else I think most people don't know, is the ERC20 standard isn't actually code. It isn't so like, okay, I'm copying an ERC20 contract. It's actually just an interface. It says, if you have a contract that says you can tell it, I want to transfer tokens, I want to get a balance of tokens, like it's a small list of things like that, we call that an ERC20 contract. How you implement that inside is totally up to you. And so there are definitely people that have sort of come up with template ERC20 contracts, say, well, here's a good way of building a token that meets that standard. And so people do this, but what people are doing is literally copying that code and deploying essentially modified copies of that code to the ledger over and over and over again. So this leads to a lot of just sort of unnecessary replication of code, and it also opens up this opportunity for errors in this.
Yeah.
It's
like the concept I always think of is like, let's say that I want to write a novel and I want to publish it online, and instead of having something like WordPress or something like that, I have to describe the raw instruction set to the display and the web page and the computer that's running it on what the alphabet is and how you encode the alphabet to the screen before you can then describe what write your novel. And like, for those who don't know computer programming, and I'm not a programmer, but like I've had these discussions enough to sort of go, well, just even writing the letter A on a computer screen is an unbelievable amount of code, and you're kind of doing the same thing again and again with the ERC20 contract.
Yeah, and so even if you can go out there and say, well, someone has implemented this piece of code that defines the letters of the alphabet and does all this stuff for you, why are you making the developer copy that code over and carefully only modify the parts they care about and redeploy that? Why isn't that just a feature of the platform? So anyway, this gets to the ask owner thing that I'll get to. But starting at that token level, if you force people to do that over and over again, what it means is that adoption of standards like that becomes very slow. So, Ethereum, really, for being the premier DeFi platform today, is moving really, really slowly to adopt these things. It takes a long time. It's like, well, we're going to all agree on a standard for NFTs and these other things because there's this issue of multiple implementations of this, and not really it is very difficult for momentum to coalesce around standards because of the way these things are set up. And also it just becomes a burden for developers, as you're talking about. So tokens are one thing, but you can say, well, why can't, as a developer, why can't I just come to the platform itself and say, I want a token just like everyone else's token, except I just want to give it a different name. Why can't I do that? But it even moves beyond that. For example, why can't you extend that notion to say, look at automated market makers, for example. There are tons of different automated market makers, which are basically just more or less slight variations where, well, we've got a more complex formula for doing this, or we manage our LPs a little bit differently, but there's a similar concept there. And so again, once again, people are just taking the entire Uniswap code base and sort of copying this whole thing over and say, we want this, but we're going to modify it a little bit and then deploy Sushi Swap or something like this. Right. Why isn't there the notion of why can't, once that becomes standardized, once people go, yeah, I want an AMM, but I just want it a little bit like this. Why can't that be something that a developer says, great, I've created a really great generic AMM, and allow another developer to say, yeah, I want one of those too. Except I want to set the parameters for this is what I want my algorithm to be. This is what I want the tokens I want to support to be, and then just instantiate that.
Right, but where that instantiation is not pushing the entire code base to Ledger again, it's referencing the code base that's already on the Ledger and going that, but with these parameters.
Right.
And one of these things that I talk about a lot as a really important concept of public decentralized ledgers is emergent standards, the ability for emergent standards to occur, that you don't know what the standard's going to be. We don't know what the standard for equity issuance looks like yet. We don't know what the standard for bond issuance looks like yet. We don't know what the standard for, capital efficient stablecoins looks like yet, or things like that. But once it happens, you get this sort of momentum effect where people want to push that wave very quickly as soon as it occurs. And what this is all about is going, we're not going to be prescriptive in what standards emerge, but we're going to make it very easy for standards, once they emerge, to be adopted in a very safe, very fast way.
Mm-hmm. Right. And what that allows you to do is, when you fail to have something like that, when you have this mechanism that Ethereum forces you into, what it does is it just multiplies the effect of the easy and safety problems we said. It basically means that now I have to deploy not only the piece of code that I care about, that I've built for my business logic, I have to deploy all this other code that I've borrowed from other places, and I have to make sure that I put this all together in the same way. And I've deployed this sort of mass of interrelated pieces of code. Sometimes even, for efficiency reasons, sometimes people even have to kind of take what would want to be multiple pieces. This gets into the composability thing. These are very interrelated things, but you could take what wants to be separate pieces of code and you end up sucking it together into one smart contract, because that's the only way in which you can get your arms around making sure this all operates safely. But again, in the end, you end up with something that's very difficult to analyze for safety, is very complex to understand how to build it in the first place. So it just multiplies the effects of the things we talked about before. And what you really want is something that is more like, it's taking if you think of the GitHub philosophy, or even the Unix philosophy, of this idea of the open source community has been created around this idea that there's a lot of smart people that are solving a million different problems, and you should be able to go out and find other people's solutions to those problems, where it's this guy cares nothing about writing this algorithm in a really good way, or this guy's written a great library for solving this particular problem. Rather than re-implementing that, you're not copying that code. You actually can reference that code. You can pull it into your project. You can compile, and you can go on and you can build things on top of that. The problem is when you're on a decentralized ledger, it kind of breaks the model a little bit, because you're now like you have to push your code out to this shared resource, into this, it's sort of this, in some ways it's going back to the mainframe era. You have this shared mainframe where all this code is operating together. So why do you have this mechanism that's outside that system entirely, where you have to go, okay, I'm going to cobble together all this code and copy from people, and then I'm going to push it onto the ledger? Why don't you have an on-ledger mechanism that allows you to reference great pieces of code within that environment? And this allows you to basically like supercharge what we get out of the Unix philosophy and the GitHub philosophy. It means that you can actually use people's deployed code, and you can see that it's well supported and it's functioning properly. You should be able to, this bridges to the composability point, you should be able to just compose those pieces together and focus on writing just the piece of code that you care about, that's actually unique, that does the thing that you need for your business idea.
So on that, let's move to this idea of composability, or the last sort of key attribute of the way of building on top of these ledgers should be this concept of being composable.
Yeah, we've kind of backed into it, and so there's two parts of it, from my opinion. Well, two big important parts of composability. One is what I just mentioned. You should be able to freely pull together different components of things and have that turn into a usable DApp in the end. You know, a DApp is really sort of a collection of code, and so.
Right.
You should
without duplication, right? Like going like
right.
the ledger already knows how to execute this thing, so let me just pull that execution primitive into my thing, and then that thing over there. But as you've already said, not reinstantiating every single time.
Right. So another way of expressing this type of composability is basically modularity. What we really need is a smart contract environment that encourages modularity rather than discouraging it, which is really what EVM does today. Like right now, the way like fees work, and the way, and then because like anytime if you have all pieces of code are kind of separated into these different silos. So if you have two different smart contracts, all they can do is just send messages, and every one of those messages becomes an opportunity for failure. So people tend to just draw their code together into these big monolithic things. What you want to do is encourage modularity, because modularity is how all good mature code is written. So that's one part of it. The other big part of it is, I think when you talk about composability, it's actually what most people think about, particularly if you're familiar with DeFi right now, which is cross-DApp composability. This idea that, well, I can write a yield optimizing application, and that yield optimizing DApp, or that smart contract, is behind it making use of 3 different swapping protocols, a lending protocol, like a leverage protocol, and it's pulling these things all together in something which allows you to provide something new. You can say, well, you can put your money into this pool and it will automatically distribute that around to make a good yield for you. So that kind of composability is huge, and Ethereum has done this really well. Like Ethereum invented this idea of you can have multiple apps that can communicate to each other, and they can do so freely. You can communicate, any DApp can communicate to any other DApp on the network in a single transaction. And that's basically what made DeFi possible in large part. However, the issue with that is going forward, we're looking out into the future, because this is where we start getting overlap with the scalability problem.
But there is a separate point before we talk about the scalability problem. There is a separate point that I didn't realize until quite recently, and I thought was fascinating, is that composability isn't really exactly a native feature of Ethereum in the way you think it is. Like the way I thought it was. Like very often, if you want to compose several DeFi applications together, you have to write another smart contract to do that thing. You can't just go to all of the smart contracts and say, hey, I would like you to send this token to this one, and then this token from this one, and this one from this one, and that's all happened atomically. You actually have to write another piece of logic that exists on Ledger to do that, and these interfaces are non-standard, and so sometimes you'll have like, and the smarts, the flash loans is a great example of it. Is like to enable a flash loan, every single DApp implements it slightly differently. So the Aave flash loan implementation is different from the compound implementation, and the flash swap on Uniswap is different again. And this is partly because of the non-modularity of the code and the way that they built for efficiency of gas for their particular execution framework. And also just because Ethereum doesn't really force or help standards to emerge at all. And so you actually, it's not as composable as people think it is. It works, but it's hacky.
Yeah, it's true. I mean, the flash loan's a good example of this, where you have a flash loan enabling function on Aave and these different protocols, but actually doing the flash loan again requires you to deploy your own smart contract. Like, you have to deploy a smart contract that goes, okay, this contract this is because, again, like EVM, everything in the EVM is a standalone smart contract. Anything you implement has to be its own standalone smart contract. So what you have to do is say, okay, I'm deploying a smart contract to the network, and what it knows how to do is go and use Aave's flash loan function to take out a loan, and then I'm going to go use it specifically to take advantage of this arbitrage opportunity on SushiSwap or something like that. Like, you have a smart contract that does that. You can't just do that in a transaction and say, like, okay, right now I can see this arbitrage opportunity. I'm going to structure a transaction that makes this loan, takes advantage of this, repays the loan, and I get my return. You have to deploy the smart contract to do that. So yeah, it is. I think this is that limitation is going to start becoming more and more important to people as there's more composability that people desire to do. This starts to become a burden.
And as it becomes more, like, as more users come into it, they'll more and more not accept this idea of every time you want to, so because you have this combinatorial problem, right? Like, the more dApps there are, the more smart contracts that have to exist to interface between those dApps, which means more like services have to exist for you just to be able to interface between them. And anyone who's used Zapier or any of these like great applications knows that you have to wait quite a long time for a new thing to be integrated, which can be incredibly frustrating. It's like, I just want to zap, some USDC into this particular pool that's just come out, but that won't happen until Zapier integrates it. And
right.
And
they can't, and you should, if we think about ideal solutions to this, what you'd like is a platform that allows something like Zapier to offer composable or compose transactions with the users at the transaction level. What they'd like to be able to do is say, like, ooh, we can see, we can structure a transaction for our users in our wallet application that says, okay, I'm gonna send tokens to this thing, I'm gonna take those tokens, do this other thing, and get this, and then it's pass the result back. As it is, they have to, like, behind Zapier, like, the wallet has to deploy its own smart contracts. You even see this with like stuff like Gnosis Safe is another. It's a really nice application on Ethereum that provides you with multi-sig capability. But again, it's not as if they can just sort of like implement this. They have to like implement this separate multi-sig contract, which does its own thing. So like, it's everything becomes, you fail to have this easy composability at the level you would like it to have. And you can see how this kind of points to the things that we're doing with Radix Engine. But there is like generally this threat to that level of composability if you look out into the future, the scalability problem, because if you look at the majority of scalability proposals, all the way from Ethereum 2.0 to other things like Polkadot and all these other different protocols, they almost always are achieving scalability at the expense of composability. This has actually been some controversy just in the Ethereum community of like Ethereum 2.0 continues to be sort of scaled back and back to something smaller and smaller because people are, the feedback has been people are afraid of the full scope of this. It's like we got to solve the scalability problem on Ethereum, and so then the proposal comes in. It's like, okay, we're going to do this. We're going to do all this sharding, and by the way, what this means is that now your smart contract, you're not going to be able to just directly call another smart contract and compose this way. Now you're going to have to rewrite your smart contract to formalize these like receipts, or you're going to send a message to the other shard saying, I would like to do this thing, and the other shard goes, great. I am willing to do this thing, and I will send you a receipt for that if you would do this other thing. And they goes, great, I see your receipt. I will now vouch for the fact that I will do that thing. And then both of them can agree to do the final transaction. And all that complexity is pushed onto the developer. So, right. In a very technical sense, you can say, well, yeah, it's still composable. You can still do cross-shard transactions. What's the problem? But from a developer point of view, you've taken something which is already, it works, but not ideal, and you've made it massively more complicated. And yet again, you can imagine all the other additional opportunities for error and like mismanaging that. Like, oh, I used this receipt when actually it wasn't finalized, and then I sent $1 million up to somebody as a result.
I don't know why it automatically makes me think of like a very visceral idea of like a user, like imagining a shard is like just a person standing by the edge of a cliff, right? And he can't see anything beyond the cliff, and a user comes along and goes to the shard and just goes, hold my beer, and then jumps off the cliff, and the guy's just stood there going, is he dead? Is he coming back? Like, how long do I hold this beer for? And so you have all of this like extra problems that are created, which actually like also means that things don't happen in a single transaction, which a lot of the arbitrage opportunities and the liquidity that's being driven by DeFi all rely on. Because I don't know if people remember Ether Delta and like the first generation of financial applications that existed on Ethereum didn't have this idea of single block transaction time for an execution. What it would be is like you would authorize something and you'd have to wait until that authorization had completed, and then you would request something and then you'd have to wait for that to complete, and then you would get something back at end time later, and like it meant that you didn't actually know what your price was and until a bit later. You didn't know if you definitely got it. And then things like Uniswap completely got rid of that by having this idea of being able to swap something autonomically in a single transaction. And then the composability came on top of it, where you could get multiple applications to do it all at the same time. And then when you shard it and they exist on different shards and you've got all of these read receipts, you now have multiple blocks that have to happen before the next thing happens. We already know what that looks like. We already know that failed.
Yeah, and by the way, this composability, again, because tokens are implemented as their own smart contracts, even if you're just Uniswap, you still have to do composability just to communicate with those tokens, smart contracts. So part of the solution to composability is really the fact that like, let's minimize how much of this coordination between applications even needs to happen in the first place. Like, why do you need composability to be able to just do simple token-based things? So, like thinking towards the ideal solution to this is we need something that we need to reformulate the smart contract platform itself so that code can be modular without friction, so that apps can be connected together without compromising on scalability, and you need to be able to freely interact with tokens without that cutting into without adding additional complexity. And, like this is where you see a lot of the, like some of the compromise positions I've seen on scalability platforms to say, well, we're going to put all the tokens on this one shard, and then we're going to put the smart contract logic on this shard. It's like, they kind of need to be together. Like, this is the point, is that they need to be able to interact with applications. But it's like, once you start doing that, once you start like, well, okay, we'll start putting tokens over here. Now all of a sudden it's like, well, you're just going back to having a single shard again, and you haven't actually solved anything. So like, you can't solve this only at one layer. This really has to go all the way down to the consensus layer. And this is why Cerberus, if you read into some of our Cerberus information, like Cerberus was designed from scratch to enable scalability that works all the way up at the application layer. And the way in which we formulated the Radix engine to run smart contracts is designed to be able to translate down to this sharded cross-shard consensus mechanism that we've invented with Cerberus. So this gets to the point of the whole thing.
So easy or intuitive, safe, reusable, composable, and this is what we think we've achieved with Scrypto. And the first, as I said, the first opportunity to see that's going to be the 12th of November, which is going to be our Alexandria preview event in New York. Before we sort of wrap up, is there anything else you'd like to sort of talk about on this topic?
I'm going to put my normal plug in that this is kind of a message to our community, because I think a lot of them are going to be reading this. Like, we really need you guys to start getting involved. Like, right now, we're just starting this ramp up. So, information like this, we're going to be starting to talk about the problems that people have in the ecosystem today, and then we're going to be talking about how Radix Engine addresses these things, and then we're going to be talking about Scrypto, how that allows you to access these features. We need to get the community. We need to get you guys and turn you guys into true believers of what we're doing here. Like, you guys need to understand the scale of this problem. You need to understand what's wrong with Solidity today and what these problems are, and then understand the nature of our solution. Because what we're trying to do with Alexandria, we'll get to this, is build a community of developers that understands just how powerful this difference is. If we can provide something that is safe and easy and reusable and composable, this becomes an enormous opportunity for developers to start building the next generation of DeFi that isn't constrained by what it is today, that starts to go out to the wider world and starts to create this financial revolution that we think is possible. So this has to start with our own community. So, we want to bring you guys along. We're going to be talking a lot to you guys, and we want to turn you guys into experts on what we're doing here, so that you can then build the first code, that takes advantage of this, and show the world what's possible, because it is a different paradigm. This is one of the big challenges we have is showing, a Solidity developer today, when we talk to them, they're going to be very skeptical about what you're saying. Well, we've got a new smart contract language. They go, oh my God, please don't change the language. Can we just focus on Solidity? Like, this is the response you'll get. We need to be able to as a developer, you need to be able to prove to the world that's like, no, this is worth the transition. This is finally solving the problem in the right way. Look at this code. Look at the comparison between these things. We're going to do some of this, but we need your help. We want you to show this is what it takes to build an automated market maker on Solidity. This is what it takes with Scrypto. We need to be putting those examples out there and demonstrating, not just talking about Radix, but showing this is a better way of building. Come join us on that journey. Join us in this community so we can start to grow that and expand. So I'm going to keep repeating that message over and over.
Awesome. Oh, well, on that note, it's been wonderful talking with you. Looking forward to the next session, and thank you so much for your time, Matt.
Of course. Talk to you soon.